Okay, first of all, who can define covalent bonding? Who can define covalent bonding? Abdurrahman Al-Jiban.
Covalent bonding are atoms that are held together by sharing electrons.
Okay, who can give me another way to define covalent bonding? Turki Al-Mijhan.
So covalent bonds, mister, are when electrons are being shared between two atoms. That is the way of them holding their structure.
Okay. In covalent bonding, we can define covalent bonding as a chemical bond result between two atoms when they share each other with valence electrons. With valence electrons. Okay. What is the name of compound that consists of covalent bonding? Mazen.
covalent bonding اتوقع teacher it's diatomic molecule لا molecular compound.
Molecular compounds. Who can define molecular compounds?
مازن ادري ايش صار.
I need Fahad.
Okay.
Fahad. Can you define molecular compounds?
Can I say it, teacher?
Fahad. Abdullah Al-Mangoor. Your mic, Fahad, is still not working. I can't hear you, Fahad. Okay, let's hear Abdullah Al-Mangoor.
Yes, teacher.
Can you define molecular compounds?
Molecular compound. Yes, teacher. It's a compound composed of molecules. Yes, teacher.
Compound composed of molecules or compounds that results from covalent bonding. Okay? Now, who can define a molecule? What do we mean by a molecule?
مازن ادري ايش صار.
Turkey.
Okay, so a molecule is a neutral group of atoms joined together by covalent bonds.
I didn't hear you clearly. Please.
Okay, I'll say it one more time.
Repeat.
So a molecule is a neutral group of atoms joined together by covalent bonds.
Neutral group
of atoms joined together by covalent bonds.
Joined together by covalent bond. Neutral group of atoms joined together by covalent bonding. That's it?
Yeah.
Okay. Who can define diatomic molecule? Badran. Can you define
yes.
molecule?
So the diatomic molecules are molecule composed of only two atoms.
Molecule composed of only two atoms. Okay, who can give me an example of diatomic molecules?
Hydrogen.
مازن ادري ايش صار.
Faisal Al-Dosal.
Oxygen.
Oxygen. What is the molecular formula for oxygen?
H2O.
Oxygen.
مازن ادري ايش صار.
Sorry, O2.
O2. Who can give me another example of diatomic molecules? Abdurrahman,
Yes, teacher.
Can you
Carbon
give us
dioxide.
different examples of diatomic molecules?
Carbon.
Yes. Carbon dioxide.
Carbon dioxide. How many atoms in carbon dioxide?
No. Hydrogen. Okay. Hydrogen is
Hydrogen. We
H2.
mentioned hydrogen.
Nitrogen.
Nitrogen. Another one.
مازن عدد.
Fluorine.
No, Abdurrahman.
Yes, fluorine.
Chlorine.
Fluorine. Yes,
Okay.
yes.
Chlorine or chlorine. It's all right. Bromine.
Iodine.
Chlorine.
Selenium.
Selenium. No.
Sulfur. Phosphorus.
No.
There's only 7 diatomic elements.
We have only
Yeah.
7 diatomic molecules. Hydrogen, nitrogen, oxygen, fluorine, chlorine,
Iodine.
bromine, iodine.
Yes.
Okay. I want to give you an example of triatomic molecules. Who can give me triatomic molecules? An example of triatomic molecules. What do you mean by triatomic molecules?
Three.
It has
elements.
three atoms.
Okay. I mentioned one exists in nature. Okay.
Yeah.
Turkey.
Yes.
Do you
So
remember
ozone, Mr.
what?
Ozone.
Ozone. Yes,
Ozone.
Turkey.
Ozone.
Yeah,
It is
ozone,
an
Mr.
element exists in nature. Okay, in the
Yeah.
atmosphere, in the stratosphere layer. Okay. Who can define a molecular formula? A molecular
مازن عدد.
Mazen.
مازن عدد. Okay, molecular formula. A compound composed of molecules. It is a compound composed of molecules. Molecular compound is a compound composed of
Can you
molecules.
repeat your definition, please?
A molecular compound is a compound composed of
molecular
molecules.
formula. Define a molecular formula.
Oh, molecular formula is the chemical formula of a molecular compound.
Of a molecular compound. What it shows us, what we can know from the chemical.
It shows,
define it,
teacher,
teacher.
it shows how many atoms of
chemical
each
formula
element
of a
a
molecular
substance
compound.
contains.
How many atoms?
Atoms of each element a substance contains.
Okay. How many atoms in a molecule, in a compound? Okay. Now, let's continue what we have watched in this video. But today I'm going to start the video again from the beginning. So anyone who didn't concentrate in this video yesterday, okay, or who didn't continue the video from the Google Classroom, please watch it here again, okay, for the first 3 minutes, and we will continue the new information about this section. Remember, we are in section 1 of chapter 8, molecular compounds. Molecular compounds. I'm going to start the video.
Enter to Bluetooth.
Please listen carefully. Huh?
Bluetooth connected.
We're starting chapter 8 about covalent bonding. This video is for 1, molecular compounds. Most of the elements on the periodic table are reactive because they don't have complete octets of valence electrons. Remember that only the noble gas elements begin with complete octets. So in nature, the noble gases can't exist as individual atoms. They are monatomic, single atoms. All of the other elements tend to bond either with each other or with other elements to create compounds in nature. One example is oxygen. In nature, you won't have a single oxygen atom. Instead, oxygen exists as a molecule, 2 oxygen atoms bonded together. And the formula O2 represents this. O2 is a molecular formula indicating there are 2 oxygen atoms in 1 molecule of oxygen. In chapter 7, we discussed ionic compounds. Those were...
Okay. He mentioned here that most of elements react with each other to form compounds to be stable. We have only few elements that exist in nature as monoatomic atoms.
Wait, that's it, just one. It's single.
Okay, monatomic single molecule consists of 1 atom. Okay, which elements are monoatomic atoms, molecules in nature? Which elements would react with or compound?
The noble gases, teacher.
The noble gases. Can you give us an example?
Helium, neon, argon, krypton, xenon, and radon, and oganesson.
Okay, and radon. Okay, I just want everyone to remember the first 5 noble gases. Helium, and remember the atomic number of
neon
helium is 2. Neon 10, argon 18, krypton 38, 36, xenon 54. Helium with atomic number 2, neon 10, argon 18, krypton 36, xenon
is 54.
Okay, the rest of the elements in the periodic table
are reactive because they need to be combined
with each other to form compounds.
Yeah.
The rest of the elements in nature do not exist as monoatomic molecules in nature. They react with each other to be stable, like one of these noble gases. Okay?
Okay.
Now, we have studied in chapter 7 ionic compound. Ionic compound, it is a compound, okay, consists or result from the reaction between
metals
which
and
types of elements?
Cations and anions, teacher. The positive and negative elements. يعني the metals and non-metals.
Cations. Cations, which types of elements that form cations?
Metals.
Metals. Okay, metals.
And ions.
And non-metals. Ionic compounds form when a metal reacts with non-metal. In ionic compounds, there is a share of electrons or what?
No transfer, master. Transfer of electrons.
Electrons, teacher. And the molecular compound is a share of electrons. So the ion compound is a transfer of electrons. And the molecular compound
is sharing electrons.
Okay. In this section, we are going to study molecular compounds and covalent bonding that form molecular compounds. Okay? Let's continue.
Okay.
Crystals, solids, and they had high melting points. Other kinds of compounds have different properties. For example, water, H2O. This is a liquid at room temperature. Carbon dioxide, CO2, or nitrous oxide, N2O. These are gases at room temperature. The attractions that hold the atoms of these compounds together are not ionic bonds. They don't involve the transfer of electrons. Instead, these attractions involve sharing electrons. Atoms that are held together by shared electrons are joined by covalent bonds. When atoms share electrons, we call the resulting thing a molecule. A molecule is a neutral group of atoms joined together by covalent bonds. For example, oxygen gas consists of oxygen molecules, 2 oxygen atoms joined together by a covalent bond. Oxygen is an example of a diatomic molecule. Di is a prefix meaning 2 atoms. Molecules can consist of only one element, like O2 or H2, but molecules can be made of atoms of different elements. These compounds are called molecular compounds. One example is water, H2O. It has hydrogen in it and oxygen. A molecular formula is the chemical formula of a molecular compound. A molecular formula shows how many atoms of each element a substance contains. So H2O contains 2 atoms of hydrogen and 1 atom of oxygen in 1 molecule of H2O. There's another example molecular compound that you may have heard of, butane. Butane is that gas that's in the handheld lighters that we can buy to start, like our candles or our gas grills. The molecular formula of butane is C4H10, 4 carbon atoms and 10 hydrogen atoms with covalent bonds. These atoms share electrons to complete their octets. While molecular formulas do tell us the number of atoms that are in a compound, they don't indicate the actual 3-dimensional structure of a molecule. The formula H2O tells us 2 hydrogen atoms and 1 oxygen atom, but we don't know exactly what's bonded to what or where in 3-dimensional space the atoms are located relative to each other. However, there are diagrams that do attempt to show the 3-dimensional structure of molecules. So here's...
Now, as you see here in the slide, okay? As you can see here in the slide, let me use my pen. Now, here, the molecular formula of ammonia, The molecular formula, it shows us how many atoms of each element exist in one molecule of ammonia, How many, what types of element that form ammonia? Abdurrahman.
Yes, teacher.
What types of elements we can find in ammonia molecule?
Hydrogen and nitrogen.
And nitrogen. How many nitrogen atoms and hydrogen atom in one molecule of ammonia?
There are 3 okay. I thought you were asking me.
Turkey, mister. So for nitrogen, you have 1 atom, and for hydrogen, you have 3 atoms.
Okay. Now, the molecular formula, it shows us only types of elements and number of atoms of each element in a compound, in a molecular compound. Here we have, what is the name of this model? If this
structural formula.
Structural formula. What it shows us? What is the difference?
The hydrogen and the nitrogen.
That shows that nitrogen is bonded to 3 hydrogen.
Mazen.
But it's that it tells you that its nitrogen is bonded to 3 hydrogen atoms. 1 nitrogen atom is bonded to 3 hydrogen atoms.
And the molecular formula, it shows us there is 1 nitrogen atom and 3 hydrogen atom. What is the difference between the 2 formulas?
This teacher, it shows you this shows you how it is bonded, but this one just gives you numbers. It just tells you that there's just 1 nitrogen and 3 hydrogen atoms.
The structural formula shows us how atoms are combined with each other. Okay? Now, here we have 3 Here we have, we have two types of model. Spacing fillings molecular model and ball and stick molecular model. Okay? We can use this model in our computers to represent a molecular compound. Here we can use balls and sticks, okay, in our class to represent a molecular compound. Here, okay, who can tell me what is the difference between structural formula and perspective drawing? What is the difference here?
ترك المشهد مستر.
تفضل.
So I think that the main difference is in the structural formula, you can see which atoms are being bonded with the nitrogen atom. And in the perspective drawing, you're seeing where the electrons are being shared. For example, you have the H down south of the nitrogen. It is sharing its electron with the nitrogen, while the nitrogen atom is sharing the atom it had from the hydrogen to the other two hydrogens on the sides.
You missed the most important point here.
Hello?
Look. Who have the answer, the right answer? Okay. Look to the main difference.
Yeah.
If we draw the structural formula for a molecular compound, you can consume from this structural formula that the angle between the two covalent bonding is 90 degrees, right?
Yes.
Right? But
yes,
here it shows us what by this drawing, okay, here it shows us that the angle between the two covalent bondings is not 90 degrees. Okay, this drawing represents this structure here. Okay, the ball stick and stick molecular model. As you can see from here, the angle is more than 90. Yes, Fahad.
Is my mic okay now? Or?
Oh, yeah,
yes,
I can hear you clearly.
Alhamdulillah. Okay.
Now, in this chapter, we are going to study how we can draw the structural formula, okay, and how we can represent it by using ball and stick model, okay? That's what we are going to study in this chapter. Let's continue.
An example of NH3. In the upper left corner, we have its formula, NH3, but then there are different ways to show what this might look like in reality. So in the bottom left corner, this is called the structural formula. This is something that you will draw in high school chemistry class. So this formula indicates that the 3 hydrogen atoms are bonded to the nitrogen atom, and it uses these dashed lines to show those covalent bonds. Another way to show three-dimensional structure of this atom is with a space-filling molecular model. This is not something that we're going to draw on paper in this class. This is something that scientists use computers to create these models. Now in the upper corner is a perspective drawing. This is a lot like the structural formula, but it attempts to give it more of a three-dimensional illusion by using these little triangle shapes instead of single dashed lines to make it look like something is receding into the distance, like what these arrows indicate, or that something is coming out towards us, like what this arrow here attempts to indicate. Then there is a ball and stick molecular model. This is something that we will actually use manipulatives that we have in the back storeroom to create these things. So ball and stick models aren't something typically drawn, but they're actual three-dimensional objects that you fit together to show what molecules look like. This slide shows a computer-drawn space-filling diagram of carbon dioxide. The red circles are the oxygen atoms and the brown circles the carbon atom. And this shows that the carbon is located in between the oxygen atoms. It shows that when they share electrons, the atoms kind of smush together. It also shows us that it's sort of a linear arrangement in three-dimensional space. Here we see the space-filling diagram of water. The oxygen is the red circle and the white circles are the hydrogen atoms. You can see that this has a bent arrangement in three-dimensional space. Here's a space-filling diagram for ethanol. Ethanol is the kind of alcohol that people drink. You can see that it's a more complicated molecule than what water looked like. Here's a check your understanding question. Acetylsalicylic acid, also known as aspirin, has the formula C9H8O4. What elements make up acetylsalicylic acid? And how many atoms of each element are found in one molecule of aspirin?
Who can answer this question?
Me, Abdulrahman Jaban.
I need to hear a new voice. Ali Lasker. علي فلاتة، بدر الدوسري، بدران، صالح القحطاني، خالد، مهند. Anyone here who can answer this question?
تركي المشهد مستر. تركي مستر.
تركي، تفضل. Read the question.
So acetylsalicylic acid, also known as aspirin, has a molecular formula of C9, H8, and O4. What elements make up aspirin, and how many atoms of each element are found in one molecule of aspirin? So there is 3 elements: carbon, hydrogen, and oxygen. We have 9 carbon atoms, 8 hydrogen atoms, and 4 oxygen atoms.
Excellent.
Khalid and I'm here
From the formula, we can tell there's carbon, hydrogen, and oxygen, that there are 9 atoms of carbon, 8 atoms of hydrogen, and 4 atoms of oxygen. Let's compare molecules to ionic compounds from chapter 7. Molecular compounds tend to have lower melting points and lower boiling points than ionic compounds. Ionic compounds were formed from metals combined with nonmetals, but most molecular compounds are composed of atoms of 2 or more nonmetals. On this slide, we see water molecules and sodium chloride, or table salt. Notice that the water molecules are able to move about, whereas the sodium chloride is held very tightly in a crystal structure. Here's a picture of a water molecule. Notice how the atoms are very close together, sharing electrons, creating almost a single entity. Sodium chloride, on the other hand, is made out of sodium ions and chloride ions that are able to move independently of each other. The chemical formula for water is H2O, and the formula for salt is NaCl. So the formulas are very similar in their look. Just looking at a formula, you can't tell the difference between a molecule and an ionic compound. You'd have to think about what are the actual elements involved. Because water has nonmetals, we know that this would be a molecule. And because sodium chloride has the metal and the nonmetal, we would know that that is the ionic compound. Here's a summary of key ideas. A molecular formula shows how many atoms of each element a substance contains. The representative unit of a molecular compound is called a molecule. On the other hand, back in chapter 7, we learned that the representative unit of an ionic compound was the formula unit. The formula unit indicated the ratio of ions involved. It didn't tell us how many atoms are actually connected together into a single entity.
Okay, our homework. Okay, open your textbook, page 225 225. Okay.
Which questions, Mr.?
All of it. We need you to answer
1, 2, 3, 4, 5, 6.
بالراحة خلينا نسمع بس.
Listen check. Okay. Okay.
Okay, Mr.
Okay, Mr.
Okay, that's it for today. Thank you for your good participation here with us. Goodbye.
Thank you, Mr. for this class.
Goodbye, Mr.